today I'd like to talk a little bit about application design. During this class, as individuals and as teams, you'll have the opportunity to design and develop an application. Now, this class doesn't have enough time to talk about everything related to application design because there's a lot to it. There's design patterns, there's architectural patterns, there's so many things that go into it. But what I'd like to do is to share with you a few of the important aspects of application design, hoping that this will give you a chance to think through some of these things as a team and individually and be able to design a great application. So here we go. So let's get started talking a little bit about application design. The first thing that I want to emphasize is that as you begin application design, you have to make sure that you have clear and understandable requirements. This is often something that gets missed as we start application development. And regardless of what kind of a methodology you use, whether you're using use cases, whether you're using agile stories, whether you're documenting your requirements in a specification, whatever it may be, you need to make sure that as a developer and as a team of developers, you understand what it is that you're building. Okay, that has to be the first thing. And that does not only include user requirements, but also needs to include non-functional requirements. Things like performance, things that are going to affect the functioning of your application in a different way than the way that the user uses it. So that's really the first thing. The second, then, is thinking about the system holistically. Okay, so oftentimes this is done by an architect, but it doesn't have to be. When you think about the application holistically, what I suggest is that you put together a system diagram with a bunch of boxes. And that diagram, whether you're using UML or you're just using good old flowcharts or whatever it is, are meant to show the major systems and how they work together. So think about if you're going to be hitting a database, if you're going to be hitting other kinds of servers, web servers, application servers, email servers. There's so many different servers. And then, of course, the application itself and how they're going to communicate with each other. Protocols, how many connections you're going to need, all those kinds of things. But at a high level is really where you want to begin. So here's kind of a bad example, I think, of that. But you got boxes, you got lines, but you don't have a ton of detail. Okay. The next thing that you want to do now is really design the application. So think about, as you think about the different connections between different systems, the different kinds of things you want to do, you often start with patterns or design patterns. MVC is actually an architectural pattern, but we kind of group it in with the design patterns. Inversion of control, the strategy patterns, singleton pattern. If you're going to be connecting to various systems like a database, you need to think about things like factories. How are you going to maintain multiple connections? Also, start to think about the different components. Most applications have some kind of an object model. That is, as data comes in from various places, it all goes into a set of objects. Those are data objects or whatever you want to call them. You need to think about the UI, but not design the UI. Just think about the different pieces that might make it up. Another important part of an application is business logic. This often falls into the controller piece of MVC. DAOs are things that manage connections to databases and to other systems and should be a part of your component diagram. Think about how then you're going to keep these different components separate from each other. Now, why do you want them separate? Well, you want to be able to swap them out as you need to. And what I mean by that is if you hard code everything together, tightly coupled, and you want to go from a web interface to, let's say, a mobile application type interface, you're going to have to rewrite the whole thing. But if you keep them loosely coupled, then you're able to swap things out here and there. MVC can help you with this. The strategy pattern can help you with this. If you're wondering about the strategy pattern, a great place to find it is in the Head First Design Patterns book. Inversion of control is a wonderful pattern that's used extensively these days. Spring is a good example of where inversion of control is used. All of these things help. And then the last thing, and oftentimes something that's missed, is what we often call cross-cutting concerns. Things like logging, things like security. We need to make sure that these are a part of our design. And these are things that cut across all aspects of your program, not just one piece. Next, so here's just a quick example of how you might start the design part of your application. Certainly a class diagram is a nice place to start. Sequence diagrams can go into that. State diagrams for more complex algorithms can be a part of your design. Now, you need to document this stuff. Now, you don't have to have a final document before you start doing development, but write down each of these components and talk about what each should do. This is not for anybody but your team at this point in time, okay? Document the patterns you're going to use. And the contract. The contract is the interface that's exposed from one component to another. Now, the reason why you're doing this is so that when you do divide up the work, everybody knows what they're supposed to do and how their part fits in with the others. And then the other thing that I would think about when you're documenting is there anything that you would want to know a year from now, because you're going to forget all this a year from now, that when you come back and have to make changes to your application that you would really want to know. Then the design or the document becomes really something for the future. Okay? Now, the last thing I want to talk about then is dividing up the work. So the first thing you have to think about is there any sequencing dependencies that need to happen? Do you need to build this component before you build this component? Usually that's a sign that there's some problem with your design, but they do happen from time to time, and so you need to make sure that you're aware of them. The next thing is think about the strengths of your development team. Some developers are much better at doing, say, UI design than back-end design like databases or other things. And others are much more comfortable in the middle, meaning things like controller, things like model. Okay? Make sure that your assignments are very clear. And again, that the contracts, meaning the interfaces between components, are spelled out very clearly. And then the last thing is, regardless of what kind of a methodology you use, you need to be checking back regularly, communicating often, and iterating as you go, because you're not going to get it 100% right the first time. Allow for that iterating. Okay? That's why I am a huge advocate of agile methodologies like Scrum, for instance, because they bring these three things together. But regardless of what you use, it's so important that you're working together as a team, that you don't allow more than a few days to go between having those kind of conversations that you need to have. Scrum has what we often call the daily Scrum. And that daily Scrum is a time for you to have these little conversations that help with collaboration. So regardless of how you do it, it's important that you have the communication flowing. So I know this isn't tons of detail about designing your application, but I really hope that it will help you to be able to get the ball rolling.
It turns me upside down. Summer, summer, summer.